All right, let's dive into one of the most radical and honestly exciting new ideas in physics today. We're going on a journey that challenges, well, pretty much everything we thought we knew about where our universe came from. So I want you to forget what you learned in school for a minute. We're going to explore a theory that starts with a truly mind-bending question. What if the Big Bang, that moment we all think of as the beginning, wasn't actually the start of the story at all? And it goes even deeper than that. What if space-time itself, the literal stage where the whole cosmic drama plays out, isn't fundamental? What if it's more like a secondary effect, a character that just showed up later in the play? Now, to understand why we would ever need an idea this wild, we have to start at the scene of the crime. See, there are these deep, deep cracks in our current story of the universe. Paradoxes that are basically screaming at us that we're missing something huge. And here is the main event. The central conflict in all of modern physics. We have these two absolutely magnificent theories. On one side, you've got general relativity, which describes the big stuff, planets, galaxies, with this beautiful, smooth, continuous geometry. On the other side, you've got quantum mechanics, which describes the tiny stuff, atoms, particles, and it's all weird and jumpy and based on probabilities. The problem? They hate each other. They just don't work together. And when you get to the most extreme places in the universe, like the Big Bang, they both just throw their hands up and break. And this epic disagreement leaves us with this laundry list of problems that keep physicists up at night. Seriously, why does reality seem to wait for us to look at it before it picks a state? What is actually happening inside a black hole or at the Big Bang where our math just gives us nonsense? And time. Why do we feel it moving forward, but our equations don't really care? These aren't small details. They're giant neon signs telling us a huge piece of the puzzle is missing. And that, right there, brings us to this radical new lead in our cosmic detective story. This is a new hypothesis that doesn't just try to patch the old story. Oh no, it rewrites the entire beginning. So here it is, the big one, the idea that everything else hinges on. Space-time is not fundamental. It isn't the bedrock of reality. It's something that came later. Now, to even begin to wrap your head around that, we need to talk about a really key concept. And that concept is called emergence. And you know what? It's happening all around us. Think about it. You've got a bunch of individual neurons, each one following some pretty simple rules. But together, somehow, they give rise to the insane complexity of consciousness. Or a flock of birds. Each bird is just trying to stay close to its neighbor. But what you see is this beautiful, flowing, complex pattern in the sky. The idea here is that maybe, just maybe, space-time itself is an emergent property, just like that flock of birds. Okay, so if space-time isn't the bottom layer of reality, then what is? Well, this theory asks us to go back, way back, to a state before our universe, before time, before space, to a place where there were just two fundamental principles. Picture this primordial duality. On one side, you have pure potential energy. It's the raw capacity for everything that could ever happen, but it's totally dormant, not doing anything yet. And on the other side, you have non-linear gravity. Now, this isn't the gravity we know and love. It's a pure principle of relationship, of structure, but with nothing to actually structure yet. And for who knows how long, they just coexisted. Two sides of a coin that hadn't been flipped. So how do you get from that quiet, primordial state to, well, all of this? The theory says it wasn't a single explosive bang. Instead, it was a logical domino effect cascade that unfolded in 8 distinct phases. This is the moment-by-moment reconstruction of the crime. Okay, let's walk through this step by step. First, those two principles, potential and gravity, they couple, they become linked. This immediately activates the potential energy. But here's the problem. Their very natures are in conflict. One is static potential, the other is dynamic relation. This creates a kind of unbearable ontological tension. It builds and builds until it hits a breaking point. And at that moment, something has to give. That release is called ontological decoherence. It's the moment all that pure potential collapses into actual real events. And from that one single moment, everything we know and love just cascades into existence. The sequence of those events creates what we experience as time. The stable relationships between those events create what we experience as space. And the energy that gets trapped inside those new structures, well, that's what we call mass. So just think about that for a second. The birth of our universe wasn't an explosion happening in space. It was the release of a deep, fundamental tension that created space itself. It was the universe resolving a paradox at the very heart of its own being. So that's a beautiful story, right? But here's the billion-dollar question. Does it actually help us with anything? Does this new story solve those nagging paradoxes we started with? Well, let's go back and see if we can finally close the case on some of physics' biggest mysteries. And here is the payoff. This is so cool. The singularity problem? Gone. The Big Bang wasn't a point of infinite density, it was a phase transition, like water freezing into ice. The problem of time? Solved. Time isn't fundamental, it's an emergent property that comes from things actually happening. The weird measurement problem in quantum mechanics? It gets a whole new look. That collapse isn't caused by us looking at it, it's a real physical decoherence event. And, maybe most importantly, general relativity and quantum mechanics? They're not actually in conflict. They're just describing reality on two different sides of that primordial transition. One describes the before, the other describes the after. Now, I know what you might be thinking. This all sounds a little philosophical, right? A bit like a creation myth. But here is where it gets real. This isn't just a story. It's a scientific theory that makes specific, hard, testable predictions. This theory really sticks its neck out. It predicts several unique things we can actually go out and look for. For example, it says there should be basically zero primordial gravitational waves left over from the beginning, which is the complete opposite of what standard inflation predicts. It also says we should see a very specific kind of lumpy pattern in the cosmic microwave background radiation, the baby picture of the universe. These are concrete clues that could either prove this whole idea right or smash it to pieces. And this is probably its boldest and most beautiful prediction. This value, R, is basically a measure of how strong those gravitational waves from the Big Bang are. Most models say it should be a small number, but definitely not zero. This theory says, nope, it's zero. Or, really, really close to it. That means if our telescopes ever get a clear signal of those ancient waves, this entire elegant idea comes crashing down. That's how you know it's good science. It's willing to be wrong. Let's end on what might be the most profound reversal of everything we thought we knew. We've always learned that mass creates gravity, right? Big objects bend space-time. This model flips that script completely. It says a primordial, relational form of gravity had to exist first to provide the framework, the structure within which something like mass could even come into being. And that leaves us with one final, absolutely massive question to ponder. If the stage of the universe, the clock of the universe, and even the actors on the stage are all secondary effects, if they're all just emergent properties of some deeper process, then what in the world is reality, at its most fundamental level, actually made of?